Hello, and welcome to the next section. So today, as I try and figure out how to make this screen bigger, is going to be sedimentary, igneous, and metamorphic rocks. Woo, rocks! So you've already gotten a little bit of an explanation when we went through the rock cycle, so we'll just go pretty quickly through this. The objectives are going to be to explain how sedimentary rocks can form from sediment, classify sedimentary rocks as detrital, chemical, or organic in origin. We're going to recognize magma and lava as the materials that cool to form igneous rocks, and we're going to compare and contrast magma and lava. We're also going to compare and contrast intrusive versus extrusive rocks. That's igneous as well. And we're going to talk about basalt and granite. And then the last thing we'll do is go over metamorphic rocks and review the rock cycle again, so you know exactly what to talk about on the tests. Okay, so sedimentary rocks. How do they form? Well, they form by becoming sediments. And so sediments are tiny bits of rocks that have been removed from the source. So the source is just a bigger rock, basically. It's through weathering and erosion. So we should kind of know what weathering and erosion is, but we're also going to learn more about that in the next unit. Basically, things happen like wind, water, ice, even heat that break down rocks into smaller rocks, and then those smaller rocks kind of get compressed and cemented, and they turn into big rocks again. So what a sedimentary rock is exactly what I just talked about. It's those sediments that have been pressed and cemented together to form a bigger conglomerate. And a conglomerate is just basically a bunch of different pieces of rock together. So they can also form from solutions. So that's going to be chemical sedimentary rocks. But solution basically is just water mixed with something. So that's what we're talking about. And so here we have the process of compaction and cementation. So right here we've got this loose sediment. Just imagine like a bunch of sand or something. You've got water between these pores of the loose sediment. And so this is like 1 grain of sand here. What happens is they get compacted. So what that is just more sand kind of comes down on top of it, and it compresses that sand into like just a dense ball, basically. Those grains are going to get packed tightly, and then you're going to get cementation or cementation. Yeah, cementation. So what happens is the pore space that we had here that was filled with water and then kind of got gradually smaller and smaller through compaction is pretty much gone. What we have then is these like cementing minerals, and so those are going to be crystals around those little grains. Usually it's going to be something like quartz, feldspar, calcite, something like that. And then what happens is you just get a whole new rock, basically. So that's pretty cool. Um, Here we go. Here's just the rock cycle again right here. Go ahead and take a look at that if you need any help. So, this is, again, it's just a really good example of the rock cycle. So then here, if I can get the picture to go, we've got an example of sediment and then cementation going on. So all these big rocks are sediment. So this is like on a bigger scale than just sand. And then this lid, all these pore spaces in between here that are filled up with little rocks, that's the cement that causes the cementation. So this is probably one huge boulder that we call a conglomerate. And it's just been pressed down and pressed down over years and years and compacted and cemented to form basically a boulder or a big sedimentary rock. So how do we classify sedimentary rocks? It can probably seem like it's a little confusing. Well, they're classified by their composition, and remember, that's what they're made up of. So sediment gets compacted, we know that. Compaction is just that extreme pressure that presses small sediment particles together. Just think of this. Imagine I've got a bunch of clay in my hand and I do this. It's going to compact and create like one piece of clay. Um, Compacted sediment is going to be classified by its size and its shape. And so for detrital or clastic sedimentary rocks, clastic is just another word for detrital, we're going to have these classifications like clay, silt, gravel, sand, and jagged, which is breccia. So for clay, a good example of that is shale. There's not a lot of air pockets, so it's very compacted. What it does do is it holds water very well. Doesn't have a lot of air pockets in there, but That dirt has a bunch of little micro pockets in it that water can go into. And we've got silt, and its rock is siltstone. That's going to be like a little more air pockets. It's not quite like sand or gravel, but there's more air pockets than clay. Then we've got gravel, which is just round conglomerates. So everybody knows what gravel is, so I'm not going to explain that too much. Then we have sand, and a good example is sandstone. That's probably the loosest packed of clay, silt, and sand. There's going to be a lot more airflow, a lot more air pockets, a lot more area for water to go in, but also permeate down. So that clay holds the water in because it's so compacted. The sand, it has so many air holes and air pockets in it that the water just kind of infiltrates and goes down. So when you think of the ocean, when you step on sand, it's not always wet, and that's why. And then we've got, when it's like jagged pieces, we call it breccia or breccia. And that's just like kind of the difference between gravel and breccia is that breccia is jagged and gravel is round. So really, it can be any rock. The most common compacted minerals are going to be quartz, feldspar, and calcite, like I said before, but that's not super important that you know. Quartz is going to be like the biggest one. So for detrital or clastic sedimentary rocks, we're going to think of like gneiss. That's nice. It's not gneiss, it's nice. Then we've got granite and limestone. Those are the big ones. The cementing materials, like I said before, are usually quartz, feldspar, or calcite. So limestone is going to be calcite, granite and gneiss are going to be quartz, and a little bit of feldspar. So for the chemical classifications, remember we've got detrital or clastic, then we've got chemical, and then we've also got organic. Those are the three big classifiers for sedimentary rock. So for chemical, really all it is, dissolved minerals come from a solution. And remember, a solution is water mixed with other stuff, basically. So what happens is water mixes with these minerals, they dissolve, and then they get evaporated. That water evaporates, and what's left over is the minerals. It's as simple as that. So for limestone, a good example of chemical limestone, which is a sedimentary rock, is calcium carbonate in the ocean water evaporates and then sticks to rock formations. And those rock formations, when it sticks to it, creates some sort of a limestone formation along it. So that's where we get chemical limestone from. Then we also have rock salt. Rock salt's probably like the biggest one. People do this out in like the Middle East and Greece and the Mediterranean a lot to get their salt. When you think of like Mediterranean salt or sea salt, this is what happens. So really, it's just water that's rich in salt evaporates and it leaves behind halite, which is the mineral rock salt. And so that's what we use for like all of our salt flavorings. It's basically that. And so here's just a couple pictures of halite. It can be white, pink, purple, blue, gray. It comes in all different colors. This is both halite, the green or the blue and the white. And then this is also halite. So it's pretty cool. Minerals are pretty cool. They're just a little boring. So then let's go to organic. So organic sedimentary rocks are made of the remains of once living things that get compacted and cemented. And this usually takes like millions of years to happen. So our two big examples are going to be chalk and coal. So chalk is made from microscopic seashells. Seashells are white, chalk is white. You know, when you scrape dead seashells on a blackboard, you get something. So that's why they decided to use those as for chalk. And it's a pretty booming industry, and it works really well. So then the other one is coal. That's the big organic sedimentary rock. Like that's the one everyone thinks about. And that's just basically dead plants. It's some dead animals, but it's mostly plants that got buried and compacted without being biodegraded. That's the important part. Most plants and animals get biodegraded by microorganisms, but sometimes they don't. And when that happens, when we get millions and millions of years of compaction and cementation, those dead plants and animals, they just compact and compact, and basically what's left over is that like extra carbon in an oil, and it turns into a rock that you can burn. So it takes millions and millions of years to happen naturally, but it takes us 3 seconds to take it out of the ground and burn it. So coal is pretty awesome for that, but it's also like kind of sad to think about. how long it naturally takes to happen, and then how quickly we kind of destroy that process. So let's talk about igneous rocks. These are the best rocks. Um, that's not true. I just put that there for fun. So, formation, not the Beyonce song, the formation of igneous rocks. It is essentially just molten rock that is cooled and hardened. So, we've got magma and we've got lava. Magma is inside of the earth. You cannot see it, okay? So, just remember that. Magma is inside of the earth. Lava is outside of the earth. That's the stuff you see. That's that beautiful orange, fiery looking liquid. So then we've got the distinction of intrusive versus extrusive. So intrusive rocks, if you know what intrusive means, in is the prefix for that. So they are rocks that form inside of the earth. So intrusive, inside. Remember that. What happens then is they cool much, much more slowly than extrusive, which means they have bigger grains. So the quicker they cool, the smaller the grains. And that kind of makes sense if you think about like what's in magma. There are other pieces of rock in that magma. So if it cools slower, those other pieces of rock are going to stay in that magma rather than if it cools quickly, it's just going to kind of be one piece of rock. So they have bigger grains and bigger crystals. Typically, you can see the grains and crystals with your naked eye, and that's going to be magma. So when you think of intrusive, think of magma, think of inside of the earth. Then we have extrusive. And when you think of X or like exit, it's outside of something. So these are rocks that form outside of the earth. So basically, it's magma that comes out of the ground and it cools very, very quickly, or compared to intrusive rocks, and that forms very small grains and crystals. Typically, you cannot see these grains and crystals with the naked eye. There are some minerals that I'll show you that you can actually see, but that's the really easy distinction between the two is you look at the grains. And if you can see the grains, then that means it's an intrusive igneous rock, which means it cooled on the inside of the earth and then eventually was pushed out. And then if there are no grains or you can't really see them, that means it's an extrusive rock. So it cooled outside of the earth. It was probably due to some sort of volcanic activity. Then we have volcanic glass. So this is a quiz question, so remember this. Volcanic glass is an extrusive rock that cools so quickly that crystals and grains cannot form. And I'll show you a picture. So here's intrusive versus extrusive. I'll move my head here. We've got intrusive. Look at those grains. Those little black flecks, those are grains and crystals. So you can see those very clearly with the naked eye. And here's extrusive. And these ones are ones that came out very quickly. You can hardly see the grains. You can't see them in this one. You can sort of see pores in this one, but there's no grains, no grains. And then here, there's little flecks that you can see. So those are the main differences. And then here is volcanic glass. No grains, no crystals. It looks like glass. Obsidian is a volcanic glass. So there's just a good example. Okay, so let's talk about basaltic, granitic, and andesitic. So basaltic rocks, right here is basalt, and right here is granite, okay? So basaltic rocks are dense, they're dark, they typically make up the ocean's crust. Most of the ocean's crust is basalt. And so this is why oceanic crust is typically denser than continental crust, is because they're made up of basalt, which is denser than granite. So that's why the oceanic crust also usually subducts under continental crust and makes magma and forms volcanoes and all sorts of stuff like that. Because that continental crust, when it hits that oceanic crust, and that oceanic crust over here it's heavier, so it hits it and then it just goes and goes right under, creates magma, and that magma comes back up and forms the volcano. So then we've got granitic. So I want you to think of Pikes Peak when you think of granitic rocks. They're light, they're less dense than basalt, and they typically make up continental crust. So you'll think of mountain ranges for that. And then andesitic is just a combination of both. So right here, we've got andesitic mountains. Here's the continental crust, here's the oceanic crust. They're pushing together, they're creating this mixture, and that's where you're going to see these volcanoes. Because that oceanic crust goes down, it turns into magma, and it comes back up in that continental area. So the last thing we're going to talk about is metamorphic rocks. Sedimentary and igneous rocks that are pushed down into the earth, they become molten, they get heat from the mantle and the core, and pressure from the top pushing down, they melt and change. So metamorphic or metamorphosizing means to change, okay? So pretty much any rock that changes from heat and pressure, that's going to be metamorphic. Around 5% of the crust, Most is in the mantle, just changing into igneous. Marble is a good example. That's all you're going to need to know.